took the bus this morning and now my ears are ringing.
I can actually save your ass.
All right. Pick up where we, any questions?
Probably don't know.
Physics scare them off already.
Is this a trick question?
I don't think so. It's not meant to be.
Okay. Oh, yeah. Then I'm fine.
Okay.
What was the question?
Now, when I open up the class with, are there any questions, it could be about preferably physics. It's not always. But it could be about the labs or about the class.
Speaking of labs, I told myself over the weekend, if possible, I would bring my lab to you and be like, can I improve this in any way? Do you do that?
Yeah.
Okay, cool.
If you bring it to me on, say it's due on Thursday, if you bring it to me Thursday morning and ask, I might not have time. If you bring it to me Wednesday afternoon, you might not get it back till Thursday morning. If I have a little bit of time, I can take a quick look and just hit the big stuff, but
Cool, thanks.
yep. I will not have that by the end of class though. I'm gonna make a little note, because otherwise I'm gonna look at it later and go, why do I have this?
Did I go to Jim?
Yes. Other questions? It sounded like you might have come up with one.
I was gonna ask, when do you post the labs? Because I was trying to print out my second lab, but I couldn't find it.
When did you try to post it?
When did I try to print it?
Yeah.
I think yesterday night.
Oh, well, it should have been there last night.
Okay, I'll check again. I'm sorry, the Blackboard is still confusing. It's not even.
If you go to the course site and click on modules 0 through 6 labs, or labs module 0 through 6, whichever way I have it labeled,
Yeah,
it should be in there.
okay, I'll check again.
If it's not, please send me a note or let me know somehow, because I'm pretty sure I checked yesterday.
So that means you upload it weekly.
Yeah,
Okay.
because the problem is that sometimes I change my mind about what lab we're gonna do. And the other one is, years ago, I had all of them posted, and somebody went and printed all of them out, and then I made changes. And so that's why I
Okay.
wait.
I was gonna print all of them out too.
Yeah.
All right, other questions?
Where is everyone? Did they drop out?
Not to my knowledge. The cool people are here, so what more do you want?
Fair. Good enough.
All right, so let's pick up where we left off. This first part is review. I've established an origin, a starting point, and the direction of positive. Now, the main reason I'm switching positive to that way is just because. The exercise that the other class, the AP class, went through yesterday, they kept, too many of them said, well, the right is positive. And I'd ask why, and that would stump them. Well, to the right is positive only if you say so. So I'm saying it's to the left this time, just to try to,
And this is on a coordinate graph?
a number line, big number line.
Okay. Let's just go backwards.
All right, so, I'm so used to the right being positive, I might mess up here, but we'll try it anyway. All right, so my position, positive, negative, or zero.
Negative.
My displacement,
Negative.
my velocity.
Zero.
Okay. That was not a very confident zero from someone here. Let's try that one again. And my velocity?
Zero.
My velocity?
0.
Positive.
Oh,
Like
Go
three
positive a little
positive.
bit.
My
Positive a little bit, like 1 or
positive
2.
a little bit? What does that mean?
Like 1 to 3.
Should we be counting your steps? Is that how?
No, it's just positive, negative, zero, not looking for a number.
Oh.
You're not going fast, but you are going positive.
Yeah, that positive's the answer. My displacement?
Positive.
Positive. Yeah.
And, getting messed up by that. And my position?
Positive.
Positive.
Did somebody say negative? My velocity,
Negative.
position,
Positive.
my displacement.
Positive.
Negative.
All right,
Well, was this instantaneous displacement?
overall. Displacement, if I don't put an adjective in front of it, is overall displacement.
Okay, well, you're going negative, so.
So, well, right now, my displacement is, well, actually, what is my displacement?
You were there last.
Yeah.
You were there when you started, so I'm assuming that.
That's my starting point right there.
So that's
Positive.
So you're positive.
Yep. Displacement's positive.
Your starting point was over there, I'm sorry.
Yeah, no, I flipped that just to mess evenly. All right. You had a look on your face like you had a question?
Why are you positive? Why is your displacement positive?
Displacement is where I am relative to my starting point.
Oh,
My
okay.
starting point's there on the positive side.
Okay, yes. That makes sense.
My position is negative though.
Yes.
All right, now, the tough one. The biggest mistake I see people making here is mixing up position and displacement. And for some people, thinking instantaneous displacement, not overall displacement. Acceleration, though, is the one. I've had enough students who've gotten these three perfectly right, and then really messed up acceleration. And we are, of course, talking about vector acceleration because otherwise plus minus zero doesn't make a whole lot of sense with scalars. Acceleration deals with how the velocity changes. So if I go from 20 meters per second to 10 meters per second, what is the change in my velocity?
Negative.
Okay, I was looking for a number specifically.
Negative 10.
All right, so my change in velocity, negative 10 meters per second. Sorry, I should have asked you to give me units. Am I speeding up or slowing down here?
Slowing down.
Yeah, I'm going from, let's see, about 45 miles an hour to about 22 miles an hour. If I go from negative 10 meters per second to negative 20 meters per second, what's my change in velocity?
Still negative 10.
Am I speeding up or slowing down?
So slowing down.
I go from, what does the negative mean?
Just your position.
Yeah, negative is purely direction. I'm going to, from 10 meters, at 10 meters per second in the negative direction to 20 meters per second in negative direction. Yes, absolutely.
So,
Yes, say it loud and proud.
Wait, what did I say?
You're
You're
speeding
speeding
up.
up.
That's it.
and is that velocity?
The velocity goes from negative 10 to negative 20. The speed goes from 10 to 20. Speed is a scalar.
So velocity is speed plus direction?
Yes.
Again? Okay.
Yep. So in this case, a change in velocity of negative 10 meters per second is an indication of slowing down. Here, it's an indication of speeding up. So one of the big mistakes students make with acceleration is sticking with this idea that negative acceleration means you're slowing down. No, that's not always the case. Now, to make it into acceleration, you would divide by time. Acceleration is change in velocity over time. And I have only two vectors in here. I have the vector symbol over the V and the A, or I guess technically, no, delta V is proper here. But these two, since these are the two vectors here, they have to have the same sign. So if the change in velocity is negative, acceleration is negative. If I look at a graph of velocity versus time, notice that this is just the slope. Acceleration is the slope of my velocity versus time graph. Is this slope positive or negative or zero?
Positive.
Thank you. Nice unison there. In this region right here, my velocity is negative, but my acceleration is positive. Here, my velocity is positive and my acceleration is positive. In this region right here, when my acceleration is positive, but my velocity is negative, I'm slowing down. And here, where my acceleration is positive and my velocity is positive, I'm speeding up. We can flip it to a negative acceleration. I think that's velocity time. In which region, here or here, am I speeding up?
In a negative direction.
Okay, I assume you mean down here. So my acceleration
Quadrant
is,
4.
okay, my acceleration is negative, my velocity is negative, and I'm speeding up.
So where both are negative or positive, it's speeding up. Where one is negative or positive, where one has to be negative, it's slowing down.
Yep.
Okay.
Same sign, speeding up, opposite sign, slowing down. Now, there's another formula for acceleration. This is closer to the formula based on definition, but it also turns out that acceleration is equal to the force, total force. I'm gonna write net right there later on. We'll just know it's the net force over the mass. In other words, the direction of acceleration is the direction of the total force acting on an object. So think about it this way. If I'm walking in the positive direction and someone pushes me in the positive direction, am I going to speed up or slow down? Okay, still, let's see if we can get a little bit more enthusiasm there. It's physics after all. What a great way to start the morning. Better than breakfast. If I'm going in the negative direction and someone pushes me in the negative direction,
You're still speeding up.
yeah. So if I'm pushed in the direction I'm moving, I'm going to speed up. In other words, if acceleration is in the same direction as velocity, I'm going to speed up. If I push opposite the direction I'm moving, I'm going to slow down. So are we ready for plus minus zero? Remember, I'm being
Relative to
positive that way.
origin or starting point?
For what?
You said ready for positive and negative something.
Positive zero, positive negative zero, positive zero negative, whichever order you like.
Okay.
So if I'm talking about position, I care about the origin. Talking about displacement, I care about the starting point. If I care about velocity, if I'm talking about velocity, I don't care about the origin or the starting point.
Okay.
Acceleration, I don't care about the origin or the starting point. All right, so my position,
Negative.
displacement,
Negative.
Negative.
velocity,
0.
0.
acceleration,
Also 0.
my velocity,
Positive.
Positive.
and my acceleration at that moment.
Positive.
That was the intent. All right, so my velocity,
Positive.
Positive.
and then as I come to a stop, my acceleration,
Negative.
Negative.
my velocity now,
Negative.
Positive. What? No.
Negative.
Hold on. Acceleration is positive.
wait a
What?
second. My velocity
Negative.
Negative.
is negative,
Okay.
and then as I come to a stop,
0.
0.
no, as I'm coming to a stop,
Oh,
It's
negative.
positive.
Oh, still.
Wait, what?
If you're coming to a stop and you were
decelerating is not a physics term. It's called acceleration.
Am I dying?
My velocity is,
0. No. Negative.
I heard someone say 0.
That was me.
Let's try that one again. I need it.
Okay, wait.
Obviously, I run out of room if you delay your response.
I'm ready.
You ready?
Yeah.
Okay, my velocity,
Negative.
Negative.
velocity is
I'm
relative to
forgetting
starting.
I'm forgetting to look at the thing. I'm not paying attention.
I feel like I'm guessing and agreeing this may to lose.
I'm looking for a number.
Okay.
Maybe that'll help all of us.
A same difference. Okay, we're ready.
Okay,
Yeah.
take 20. My velocity,
Negative.
Negative.
as I come to a stop,
Negative.
Negative.
my acceleration,
Negative.
if I slow down,
Acceleration is delta v
Positive
over
because
t,
you're changing.
or change t.
if I go from a velocity of -10 to 0,
I got it.
So, hold on. If your velocity is negative and you're stopping, is it not going positive because there's an opposite force?
yes, acceleration is positive.
Okay, thank you.
So when your acceleration changes, it's positive?
Yes.
No.
Reword that.
I'm saying, when you're saying that you're slowing down, even though you're coming to a stop, the acceleration changes, so it's a positive?
Your velocity changes.
Wait, but I thought you were asking about acceleration.
I was, but acceleration depends on how velocity changes.
So
An object
if
can
your
slow
veloc-
down to a stop even though an acceleration be constant. So that's part of the confusion there. As my velocity changes, I have a negative velocity and it goes to 0.
Velocity of
That is
speed
a
and
positive
direction.
change. If I go from -10 to 0, it is a positive change.
Yeah, I got you.
Or, if I'm going in the negative direction and I slow down, something's gotta be pushing on me that way, in the positive direction, acceleration's positive.
Okay.
Or, I am slowing down, so velocity and acceleration are in opposite directions. So if velocity is that way, acceleration has to be that way. Yes?
Can you show us what negative acceleration would look like?
Alright, so my velocity now,
Negative.
Positive.
Oh, positive.
You're going to the left, so you're positive.
I know,
Yeah.
it's that other group, I'm blaming them. Alright,
Dang, there's a problem with kids.
alright, my velocity,
Positive.
alright, as I slow down, my acceleration,
Negative.
Because it's pushing you that way, which is to the.
correct.
Got
So would would the acceleration be positive if you weren't slowing down? Or would it still be negative?
If I, depends, I mean, alright, so here is, my velocity is gonna be positive, and my acceleration is positive. So my velocity is positive, and then my acceleration is positive. Now, going in the negative direction, hence my velocity will be negative. So my velocity,
Negative.
thank you. If I slow down, my acceleration,
Positive.
that's positive acceleration that way, or my velocity's negative. Thank you. And then I speed up,
Acceleration is positive. No, it's negative because you're going faster still in that direction.
yeah, negative. Got it?
Yeah, I was stuck on the speed and not looking at the force.
I feel like direction is very much screwing me up.
Well, direction is a big part of vectors.
Wow, shocker.
Yeah, all right. Now the part, so a number of people can handle that, speeding up, slowing down, all right. Now here's the other part that messes with people. My velocity is positive. I turn around. At that moment that I'm turning around, my acceleration, positive, negative, or 0.
You're turning around, so it's still positive?
So I heard it's 0 and a positive.
But if you're turning around, then you're moving in a different direction.
Yeah, but I have to stop. If it, in a one-dimensional problem, if you're turning around, you have to stop.
Oh, okay.
There's no rip in the space-time continuum where I'm traveling this way at some velocity and suddenly I'm going that way. I have to stop to turn around.
Okay, well, if you're going negative and then you stop, then you're,
I was going positive.
yes, then you're positive, and then you turn around and you're going positive again. Because you were going negative at first.
No. You're misunderstanding what he's asking. So wait, can I?
Sure, going on.
So what he's trying to say is, when he's moving this way,
his velocity is positive.
Yes.
His stopping to turn around. This action of me doing this, what is the acceleration?
Negative.
Is what is asking.
Well, if you're moving that way, then it's negative. I'm thinking infamous
No, I'm not
turn,
moving.
should I not be?
I'm just changing. I'm shifting my position. It's 0. Right?
So you're not doing like
Either
this.
way, I don't know if my answer is right, but I think I'm still representing it right. I think it's 0 because you're not moving a certain way.
So it's like
Is it
if
no?
you just somehow appeared in the next direction instead of moving that way. Because what I'm
Well,
thinking is you're
I mean,
moving.
what
that
I
way.
did is I walked in this direction, stopped, and then turned around. I didn't physically change the direction I was facing, all I did was change the direction I was moving. But moving along in the positive direction, and now I'm moving in the negative direction.
Then you're negative.
So the question is, at the point of turnaround.
Okay.
So we got some votes for 0 over there.
Negative. Sounds
Got a
nice.
negative here.
Turn around. So it's true through the entire year.
All right. I will say that one of the rookie mistakes has been demonstrated here. Let's take a look at if there's a change in velocity. If there exists, shorthand notation, just because I don't feel like writing it out. If there exists a change in velocity, then there is acceleration that is not 0. If velocity changes, acceleration is not 0. Which means I'm speeding up, I'm slowing down, or I'm changing direction. Like if I'm traveling in a circle, acceleration is not 0, even if I'm at a constant speed.
Can I ask you a question?
Yep.
Velocity, vector velocity.
Velocity is always a vector.
Yeah.
But, yep.
Like, I'm writing an equation, okay? So, v with the vector symbol equals s plus direction. Is direction, since position is relative to origin, and direction is also relative to origin, is it not speed plus position?
The velocity cares about change in position, not what the position actually
So
is.
direction is change in position.
The change in position would be the direction of velocity.
Thank you.
All right.
Wait, so
Okay.
if you're driving in a circle, like you said, there's a change in velocity because there's a change in direction. Like if you're
Correct.
not changing your